Okay, what we're looking at here is question 29d of the CSSA 2015 paper. It says the diagram below shows a concrete cover used to protect the drain. The cover has a semicircular, so I'm going to underline that, cross section with an outer diameter of 4.2 meters. So the outer diameter. The inner diameter is 3.8 meters, and the cover is 2 meters long. So the inner diameter is 3.8 meters. Calculate the volume of concrete required to manufacture the cover. Now, since it's a semicircular cross section, and as you can see, it's made up of two semicircles. So if you had a complete circle, it would be made up of two circles. Therefore, what we have here is half an annulus. Now, on your formula sheet, to find the area of an annulus, its area is equal to pi lots of the larger radius squared minus the smaller radius squared. Okay, so what we need in order to find the volume, since it's a prism type shape, it's the area of the cross section multiplied by how deep it is, or its height. Okay, so the first thing we need to find is the area of this particular cross section. Now, since it's half an annulus, you can say that the area is pi lots of the larger radius squared minus the smaller radius squared over 2. Okay, so we need to work out the radii of both circles first. So what we have here, so the outer diameter, 4.2 meters diameter, which means you've got 2.1 meter radius. This one, the smaller one is 1.9 meter radius. Okay, so substituting that in, pi lots of 2.1 squared minus 1.9 squared all over 2, and that gives you an answer of area is approximately 1.257 meters squared, and that's rounded off to 3 decimal places. Okay, so that's just the cross-sectional area. So therefore, they'll give you a mark if you found that. Now you'd also get a mark if you went through the correct process of finding the cross-sectional area. Now I suspect the mistake people would make here is overlooking the fact that the 4.2 and the 3.8 represent diameter, not radii. And instead of using the radii, they would substitute the 4.2 and 3.8 meters in instead. So anyway, now we've got the cross-sectional area. To find the volume, cross-section times height. So 1.257 multiplied by the 2 meters, which is there. That's how deep it is. So that gives you an answer of 2.51 meters cubed. And that's obviously rounded off to 2 decimal places. It doesn't specify how to round off, so you round off how you feel appropriate, but making sure to stipulate how you round it off. That's it. That's how you find the volume of that particular prism type shape.